In this video, we are going to learn how to model revenue, especially for this particular company. We discussed earlier in one of our previous lessons that in most cases revenue is the key value driver for a company and that's what we would use in our financial model. In this case, being a retailer of pizzas, for this company as well, revenue is going to be the key value driver. The point of discussion is how do we define revenue, because that's what is going to define the way we model the company. At a very lower level, we could look into breaking the revenue by categories of pizzas and other food products that the company sells and multiplied by the average selling price of each of the food products. But as we think about revenue modeling, again going back to one of the lessons we learned, it is important that we understand as to what kind of targets is a management going to set its team. So you would assume that in case of a pizza restaurant, it is never going to be the case that a management is going to set a target in terms of what particular type of pizza that the company should sell, because eventually that's a customer's choice. A company would be better off as it offers more and more products, more and more choices to the customers, so that they have multiple choices to choose from and so that they can be expected to frequent the company a lot. Keeping this in mind, we would have to define revenue either in terms of revenue per customer or revenue per store. Revenue per customer is a little complicated, or rather requires a lot of information for us, which is difficult to get, and we would be better off to go with revenue per store. So in this case, we would therefore define revenue as average number of stores multiplied by average revenue per store. The two parameters, which is average number of stores and average revenue per store, might also need to be calculated. In this case, we would calculate average number of stores as stores at the beginning of the year plus stores at the end of the year divided by 2. That gives us a simplistic calculation about the average number of stores, and this would be the average if we assume that the number of stores open during the year are uniform throughout the period. In case if the company has too much of front loading or back loading of store opening, then this formula would not be suitable. But from a modeling perspective, most of us would not have much other option rather than to stick to this simplified formula for average number of stores. The next parameter, which is average revenue per store, if we look into the problem, we notice that the problem defines average revenue per store, or as relates it to a growth applied on the previous year's average revenue per store. So that's what we are going to do. Average revenue per store, which we have abbreviated here as ARPS, is going to be previous year average revenue per store multiplied by 1 plus growth rate. When we look into our problem, we do have information in terms of number of stores that were open at the beginning of the year and the number of stores that are expected to be open during the year. So this would help us to find out the average stores for 2013 and forward. However, the problem does not give us the average revenue per store. So that requires that we back calculate these numbers. And sometimes, even in a real life situation, it invariably happens that some information have to be back calculated and they might not be available ready hand. So we would also have to do that here. In order to back calculate the number, let us go to our income statement. We know that revenue is average stores multiplied by revenue per store. So if we define it that way, in here we know that the problem had given average number of stores, which was 515. So we shall use this 515. So if number of stores is 515, we know that average revenue per store would be the revenue divided by average number of stores, which is 2.5 crore per store. Now rather than keeping this average number of stores number in our financial statement, we may as well want to keep it in an assumption sheet so that average number of stores for the prior year and future year all flows in from the assumption sheet, or we may as well have it in this sheet. So let's choose the other option. So we're going to have average number of stores we know as 515. So that's a punched in number. So we're going to highlight it as an assumption, and in here we link it to that particular cell. So now let us focus on forecasting the average number of stores for 2013. How to do that? We know that average number of stores is opening balance plus closing balance by 2. So let's have these two lines, opening balance and closing balance, and we're going to say average is opening balance plus closing balance divided by 2. The point is, how do we arrive at opening and closing? We know that opening balance of a particular year is going to be the closing balance of the previous year. So we'll link it to 2012's closing balance, and 2012's closing balance would be an input number flowing directly from our problem, which is 550. Now what affects the closing balance of store count from the opening balance? Simple, addition of stores. And what reduces the store count? We know that is deletion of stores. So in terms of addition, the problem mentions that the company intends to open 30 restaurants in 2013. So that's going to be the addition. We do not have any information on deletions, which means we would ignore that. So coming back to the assumption sheet, we're going to say number of stores to be opened is 30, number of stores to be closed is 0. So in terms of our overall closing balance, it's going to be opening balance plus closing balance plus opening balance plus addition of stores minus stores closed during the year. That's 580. Now what we would also like to do is, in order to maintain certain consistency, when we enter a negative number or deletions, we would like to enter it as a negative number and then add it in our model, rather than so use addition as an operative everywhere, and any negative numbers we would use it as a enter it in minus sign. In this case, of course, it's 0, so there is nothing to enter here. So you've got average number of stores, which is perfect, great. We'll go to our financial statement. We'll link our model average number of stores to this. Next question, average revenue per store. Let's capture the assumption here, which is expected increase, or rather year-over-year increase in average revenue per store. You would notice in the problem that the increase is mentioned, the revenue per store is expected to stay flat. By flat, we assume that there is a 0% growth in revenue. So we'd go to our financial statements, we'll say average revenue per store would be 2.46 multiplied by 1 plus the growth rate in our assumption sheet. So that's the number for growth rates, and here we are going to net sales would be 565 multiplied by 2.46. That's 1389.8. We have here successfully modeled the revenue of the company. Now, however, there are certain key aspects in terms of best practice that we need to discuss now. First one is that the 2013 is a forecast year. So we need to tell the reader that this is a forecast year. How to tell that? There are multiple ways to do that. One is to have a separate color code for forecast year. Two is to have a prefix such as E or F to indicate that it's an estimate or a forecast. The problem in manually typing it E or F is that the formula gets broken down. We earlier had wanted it to be added from the previous year so that there is a continuity in the formula. Now how do we fix this? One way to fix this is by using a custom formatting tool. So we'll go to custom formatting by going to format cells, or by doing Control 1, which is a shortcut key for format cells. In format cells, we'll choose the custom category in the number tab, and in the number format, which currently is general, we'll type in a space and within quotes type in an E and click OK. You notice that it looks like a character E is typed as a suffix in the year's name, but we still continue to have our formula. Now as we keep this as a format across, it works perfectly for us. That's best practice number 1. Best practice number 2 is, as we work along, we would like to make sure that even though all the assumptions are kept in the assumption sheet, sometimes if a top management or anyone who's reading a printout of this particular financial statement, it is important that he also knows the key assumptions underlying this. So they may not have the flexibility to move into different sheets. So while the calculation is flowing directly from our assumption sheet, we may also have the same information in the financial statement as well, and there is no harm in it. We'll link it directly to our financial statements. And format it so reader can always read it. Best practice number 3, which if required we can do it, else we can leave it, is to use a named range. So let us say we need forecast all the way up to 2020. What we may as well do is we may give a name to this particular range. So rather than referring it as D9, let's give it a name as ARPS growth, or average growth in ARPS growth. So the moment we have referred it as ARPS growth, what we would notice is that we can as well start giving the formula as into 1 plus ARPS growth, close the bracket. The advantage of using a named range is that a reader who's looking into the model would automatically know what is the assumption that's being used here. Now of course it is important that we define what this ARPS is. We at the beginning of this case study discussed that ARPS is the abbreviation for average revenue per store, but somewhere it is important that whatever name you use is understandable to the audience as well. So that's one advantage, that they can look at the formula and immediately understand what it is rather than go back to another sheet and find out what that particular cell contains. The disadvantage, however, is that it does not disclose, the formula does not disclose as to where the assumption is actually sitting in the model. If somebody needs to look into the assumption, it is not that straightforward for them to find out where it is. There is of course a way to find that out. One way to find that out is to click on the drop down box, name box on top, where they would see all the names available. They can click on that, which directly takes them to it. So that's best practice number 3. As I told you, while this is a best practice, it also depends on the user preference. In certain cases it works absolutely fine, in certain cases it does not work great. So it depends on the ultimate purpose. If you need the audience just to look into and understand the formula, not really bother about editing any part of the file, then using a named range works brilliantly. If you want the audience to also understand the structure and flow and want them to go and edit, then you may not want to use the named range. Moderation is what we would recommend here. Apply your judgment and use it appropriately. Finally, another aspect we would like to discuss, which is not really from the best practice point of view, and which is that we did not populate the assumption sheet in one go. We've been populating it as and when we need. There are two approaches to it. One, come up with all the assumptions you need, populate it once, and go ahead and directly get into forecasting. The other is, wherever you need, come and keep populating the assumption sheet. We would recommend that it's much more easier when you come back to assumption sheet as and when you need to populate an assumption, rather than trying to dump all the assumptions in one go, for a simple reason that it might not be that straightforward for anybody to figure out all the assumptions required at the beginning stage itself. So that completes the revenue modeling part of it. We have already modeled the revenue. We have been working only for 2013. We have not copy pasted the formula for 2014. But what we would do is we'll first work for 1 year, make sure that our model for 1 year is absolutely fine. Then Excel allows us to smartly extend the forecast to future years by simply copy pasting the model. So that's what we would do.